All right, guys. Um, Top of the morning to you guys. So we are live, and I want to go over this particular set of questions that we have for the day. I'm very certain that at the end of this class, you'll be able to go into your exam hall and do marvelously well because the kind of questions we are going to cover are questions that will touch every aspect of chemistry and we give you uh, a beef you up for the exam you're about to write in. Okay, so quickly, let us look at the first question. The first question says that we should state the postulate of Dalton's atomic theory. But first of all, we need to understand the concept of the atomic theory. All right, when we say atomic theory, what you are talking about is simply theories that man proffered over the years till we got to this the model of the atom we have today. How that everything we see around us, everything we can find in the universe is made up of some tiny particles which they called atoms. So every scientist at their own given time actually proposed some sort of theory about what the basic units of the universe is about. So the Dalton's atomic theory is what Dalton, who was a chemist, proposed as the result of his research as to what atoms are. So the first thing Dalton said, elements are composed of extremely small particles called atoms. All right. So, which means elements, which simply means the purest form in which any kind of matter exists, is made up of tiny particles that are called atom. Which means if I add, I always use this example, a chunk of gold like so. Gold is an element. The only reason this gold is going to be this gold is an element is because if I zoom into the gold, I will not be able to find something else that is not made up of gold atoms. All right, it's going to be only gold that's in there. Okay, so that's why we say it is a gold. But if we consider water, for example, if it is possible for you to zoom into water, you will find hydrogen and oxygen. So water is not an element, which means it's not pure. It's not the purest form. Sorry, that's only it's made up of only one particular stuff. So going back to our gold example, it means if I'm able to zoom into gold billions upon billions of time, Dalton is saying that the element gold is composed of extremely small particles. So this is what I will see in the gold, in the chunk of gold. Extremely small particles. I've treated this in some other video. So while we look at this with our eye and we see something like this, in reality, this is what it looks like. Okay, so these atoms of gold that are all that are like this are the ones that make up the gold. That's what Dalton said. So that's the meaning of the first postulate. All right, and he also said that elements of atoms of a given element are identical. So, two, the atoms of a given element are identical and they differ from atoms of other elements. So, what does this mean? Let me bring in another element, for example. Let's say this is a ball of iron, for example. So, if I want to compare this iron, let's say this is iron, for example, and this one right here is gold. So, what this second postulate is saying is that the atoms that make up the gold will be totally identical. So if I come here now, if I could pick this guy out here and pick this guy out here, and compare them, I will find out that they will be identical, just the same, but they will be totally be different from the atoms that will make this ion. If we zoom into the ion, this is what we are going to see. So that's what it means. So if I single out this guy here and I bring it here, and I single out this guy, I bring it here, for example, these two will look the same, but they will be totally different from these two other guys, which means atoms of elements are identical to holding themselves, but they will be totally different when compared to atoms of other elements. That's the second postulate of John Dalton. The third thing John Dalton said, let me create some space here now. Just give me a little time. Just create some space here. All right. Okay, so I think we are ready. Now, the other thing Dalton said is that compounds are composed of atoms of more than one element. What does this mean? What he's trying to say is that a simpler way to put it is to say that when elements react, it's their atoms that do combine. So this is so what this simply means is that if I go back to my analogy of the gold atoms and the iron atoms, for example, I know it's not a very plausible example to give because gold and iron cannot react, okay? But so that you understand the concept. Well, let me say, no, I think let me take this again so that it's easier for you to get the concept. Let me use water and let me use water in the case of the reaction of hydrogen and oxygen. So if this is hydrogen, for example, and it reacts with oxygen to form water, all right, to form water like this. So let me quickly balance this up. This means that we have 2 here. Okay, oxygen is now 2. That makes this guy 4. So 2 here. All right. So if this is the hydrogen atoms and this guy is the oxygen atoms. Now, when Dalton is saying that when these guys combine to form this water, it is the atoms that constitutes them, that makes them up, that's actually combining, such that we have something like this. So I see the ratio here. For every 2 oxygen, for every 2 hydrogen, there's 1 oxygen. So this is what they will be forming. So wherever you see 1 oxygen, they will be bonded to 2 hydrogen atoms. Okay, so this is what it means. And this is very, very important. In fact, it's one of the most important postulates of John Dalton. All right. Now, the fourth thing he said is that a chemical reaction involves only the separation, combination of, or rearrangement of atoms, which means it does not result in their creation or destruction. So that's where the law of conservation came into play. All right. So because of time, we're going to stop. I think that these have answered the first question, which is the postulates of John Dalton. Now, the second question talks about we should define the term alpha particle, beta particle, gamma ray, and X-rays. So let's do that shortly. Okay, let me create some space here. So what's an alpha particle? You know, radioactivity is simply means spontaneous emission. So before you appreciate what alpha particle is, you need first of all need to understand what radioactivity is. So radioactivity is a phenomenon that was discovered uh, by Henry Becquerel. All right. So in 1890 something, I don't remember the year particularly, but I know it's 1890 something. Now he found out that a compound of uranium compound 235, that's the mass number, darkened a photographic plate. All right. Normally, prior to this time, you remember the discovery of the electron using the cathode ray tube experiment. The cathode ray was actually the electrodes in the cathode ray were connected to a power source. So the ejection of electrons from the cathode was triggered by connection to an electric supply. All right. So things don't just emit particles. Prior to the discovery of radioactivity, they get them triggered to do that. Okay. But in the case of radioactivity, they find out that the uranium that was kept in the photography did color the photographic film. All right. So they didn't understand what this was, because prior to this time, what they knew was that if you have to trigger it with some sort of electricity first. So this spontaneous emission was given a term called radioactivity. And also, they found out that regardless of the the compound that of uranium that they used, the same effect was seen, which means it wasn't a matter of the compound, but rather it's a matter of the element that uh, is radioactive. So, so that's how they got to discover radioactivity. So coming back to what an alpha particle means is, an alpha particle simply, for example, if we have a very why are elements radioactive? Because their nucleus are heavy. If the number of protons and neutrons in the nucleus, for example, let's say uranium 235 has 235 nucleons. What does this mean? It simply nucleus is just the number of protons and neutrons in the nucleus. Okay, so imagine it's this large number, 235. Don't forget that the protons are positively charged, and you know that like pair will always repel. Okay, so they don't want to be together. The uranium does not want the the it's unstable because it's not happy it's having such positive charges so in that large amount together. So it's trying to give off some of the protons, all right, so that it can relax to something else, some smaller nuclei. Okay, so when it does this, it ejects two protons and two neutrons. So an heavy nuclei, for example, like uranium 235, we eject two protons and two neutrons off its nucleus. And don't forget that the protons, the number of protons is simply what we call the atomic number, and it is what defines the type or the nature of elements we have. So imagine an uranium 235 that ejects two protons from its nucleus. It simply means it's no longer going to be uranium anymore. It's going to change to something because it has removed two protons. It's going to change to something else. All right. And if you go to your periodic table, you're going to see whatever you see that has. First of all, let us first of all get the atomic number of uranium, 92. So uranium 235 is 92 in atomic number. Okay, so let's put it here. 92. Imagine it lose two protons. If it loses two protons, it means the atomic number becomes 90. All right. So what element has 90 atomic number of 90 in the periodic table? Thorium. So uranium becomes thorium when it loses two protons and two neutrons. Okay. So it becomes thorium. All right. So these two protons and two neutrons that uranium loses, they didn't know when the first time they studied this, they didn't know that it was two protons and two neutrons. So they called it alpha particle. All right. So, but now we know what it is: two protons and two neutrons. And if you consider helium, you know helium has atomic number of 2, right? And it has a mass number of 4, which means it has two protons and two neutrons. For it to have two protons simply means that if it's a neutral helium, it should have two electrons, right? Electrons will be 2. All right. So just imagine the helium atom without the electrons. So it's like saying a helium nucleus, right? That's why they call the alpha particle helium nucleus. Okay? So it's going to be positive charge. You know why? There's no um, electron with a negative charge that counterbalances the effect of the two protons positive charges. The right side. So that's why in a magnetic field it tends to be deflected to the left. Okay. So this is what the alpha particle means.